Okay, so we're going to be looking at today, Jan 2020 Pure Free exam quick walkthrough. Okay, so question 1. Population of a rare species of toad is being studied. The number of toads, n, in the population t years after the start of the study is modelled by the equation. Okay, we've got n equals 900e to the power of 0.12t over 2e to the power of 0.1t plus 1. According to this model, calculate the number of toads in the population at the start of the study. Okay, when we're looking at finding at the start of the study, it's obviously been 0 years, okay? So we need to substitute in t equals 0, so we're going to get n equals 900e to the power of 0.12 times 0 over 2e 0.12 times 0 plus 1, okay? This is actually going to give us 900 over 3, which is in fact 300. Perfect. So, then part B. Find the value of t when there are 420 toads in the population, giving your answer to 2 decimal places. That means our total population is 420. So that means n equals 420. So we're going to have 420 equals 900e to the power of 0.12t over 2e to the power of 0.12t plus 1, okay? I need to rearrange this. I'm going to multiply both sides by 2e to the power of 0.1t. So I'm going to get, if I multiply both sides, I'm going to get 840e to the power of 0.1t plus 420, because I've multiplied it, brought it up and multiplied it, which equals 900e to the 0.1t. Okay, so I'm going to get 420 equals 60e to the 0.1t. Okay, then I'm going to get 70, if I divide both sides by 60, equals e to the 0.1t. How do I get rid of an e? I'm going to ln both sides. So ln of 70 equals ln of e to the 0.1t, which is just going to mean that ln of 70 equals 0.12t. So I'm going to divide both sides now by 0.12. So I'm going to get t equals ln of 70 over 0.12, which is going to give me 16.22. Okay, and 2 decimal places. Perfect. Then part C. Explain why, according to this model, the number of toads in the population can never reach 500. Okay, why can this never reach 500? Okay, so when we look at this, what assumption are we thinking as to why it can never reach 500? So, part 6, explain why, according to this model, the number of toads in the population can never reach 500. So if I do part C up here. So for part C, we can put 500 equals 900e to the 0.12t over 2e to the 0.1t plus 1. And then I'm going to multiply this, so I'm going to have 1000 e to the 0.1t plus 500 equals 900e to the 0.12t. So that means I'm going to get 500 equals negative 100, e to the 0.51t, and then if I divide both sides, I'm going to get -5 equals e to the 0.12t. Okay, we cannot learn a negative, okay? So this is how we know, because we cannot learn a negative, okay? So that's how we know that the population can never reach 500. Now, we can have a look. How could we find our maximum? Okay, now our maximum is, imagine as e 0.12t, okay, tends to whatever number it tends to. We're going to end up with 900 over 2, which is 450. So that tells me that our maximum value is actually 450, okay? Okay, question 2. The function f and the function g are defined by f of x equals 12 over x plus 1 and g of x equals 5 over 2 ln x. Find in its simplest form the value of f of g of e squared. Well, first of all, I need to find f of g. Okay, so we know that g of x equals 5 over 2 ln x. So f of g of x is what we're doing, is 12 over, and where there's an x, we're going to substitute in 5 over 2 ln x plus 1. Okay, so this is my f of g of x. Now, what am I going to do? I'm going to substitute in e squared where there is an x. So now I'm going to have equals 12 over 5 over 2 ln e squared plus 1. Now ln and e are going to cancel each other out, so it's just going to be 5 over 2 multiplied by 2. Okay? So we're going to have 12 over 5 plus 1, because 5 over 2 times 2 is 5, which equals 6. Part B. Find the inverse function of f. 12 over 6, which is 2. Okay, part B. We're going to find the inverse function of f. So we know that f of x equals 12 over x plus 1. Now, again, depending on what you were told in, at GCSE, some of you may remember writing x equals 12 over y plus 1 and then rearranging, okay, to get y equals. So I'm going to multiply both sides by y plus 1. So I'm going to get xy plus x equals 12. I then need to factorise out x. No, I don't, sorry. xy times x equals 12. Yes, I do need to factorise x. X is y plus 1 equals 12. So I'm going to get y plus 1 equals 12 over x. So therefore, y equals 12 over x minus 1, which is my inverse function of f of x. It then says, hence, or otherwise, find, oh wait, there, we haven't written our boundaries. So what can x be between, if we have a look here, whenever we have a function, it's always defined by our set of values. Our function here, we know that our function cannot equal 0, okay, in this case. So our x has to be between 0 and 12. So 0 is less than x, which is less than 12. Okay, we need to write down what we are defining it by here. And then part C says, hence or otherwise, find all real solutions of the equation. Okay, if we're going to find all real solutions of the equation, what I'm going to have to do is I'm going to have to multiply, put the two equal to each other. So part C, I'm going to have f of x equals the inverse. Okay, so I'm going to put them together. So I'm going to get 12 over x plus 1 equals 12 over x minus 1. Okay, so what I'm actually going to do is I'm going to multiply everything by x and multiply everything by x plus 1. Okay? So I'm going to get 12x x plus 1 over x plus 1 equals 12x x plus 1 over x minus 1 lot of x plus 1. I've multiplied everything by the denominators we had, which was x and x plus 1. Now what you're going to find is that this is going to cancel, this is going to cancel. So I'm actually going to get, if I bring that up here, C continued, I'm going to get 12x equals 12 lots of x plus 1 minus x lots of x plus 1. So I'm going to get 12x equals 12x plus 12 minus x squared minus x. I'm going to rearrange this, move everything to the left-hand side of the equation. So I'm going to get x squared plus x minus 12 equals 0. Okay. If I factorise this, I'm going to get x plus 4, x minus 3 equals 0. So I'm going to get x equals negative 4, x equals positive 3. Now, if we go back to the original equation, both equations are x needs to satisfy two things. It needs to satisfy that x is greater than 0, and it needs to satisfy that it's between 0 and 12, okay? In this case, we're going to reject the negative 4. So our final answer is x equals 3. Okay, this is our only answer. Okay, question 3. Figure 1 shows a linear relationship between log to the base 10y and log to the base 10 of x. The line passes through the point 0, 4 and 6, 0 as shown. Find an equation linking log to the 10y with log to the base 10 of x, okay? What should I be thinking straight away? Y equals mx plus c. So for part A, we want y equals mx plus c. We need to find a gradient, and lucky for us, we've been given two coordinates, just like we would y2, so I've got 0, 4, 6, 0. So y2, 0, minus y1, which is 4, over x2, 6, minus 0, 4 over 6, which is in fact 2 over 3. But if we look at the graph, we have a negative gradient, exactly. Okay, and you can see on the top, it's negative 4 over 6. Then, we don't need to work out our c, because our c is our y-intercept, which is in fact 4. So instead of writing y, I'm going to write log to the base 10 of y equals our gradient, which is m, minus 2 over 3x, which in our case is log to the base 10 of x, plus c, which is 4. Nice and easy, 2 marks. Part B, hence or otherwise express y in the form px to the power of q, where p and q are constants to be found. So, now what we need to do is use all of our knowledge of log laws to solve this. So for part B, first of all, we know a log to the x is the same as writing log x to the power of a. Okay? So log 10y equals log 10x to the power of minus 2 over 3 plus 4. Okay? But hold on a minute. we need to really, to get rid of log to the base 10, I need everything in log to the base 10. What can I need to rewrite the number 4 in log to the base 10. Okay, I know that log to the base a of a equals 1. So if I was to write k here, this would then equal k, because remember k would be moved up there. So 4 is going to be rewritten as log to the base 10, 10 of 4. Now, everything is log to the base 10. Essentially, we can cancel them all out. So we're going to have y equals x to the power of minus 2 over 3. Now remember, the plus, when we add logs, that's actually the same as multiplying the interiors, isn't it? Okay, so this is multiplied by 10 to the power of 4. Okay, and 10 to the power of 4 is 10,000. So y is going to equal 10,000 x to the power of minus 2 over 3. Okay, I have skipped a few steps, but just remember that log of a plus log of b is log of ab. Okay, and then once you've got logs on both sides, so then essentially I had log of y equals log of ab, so that means y equals ab. Okay, so this is back to pure 2. So there we have it. Question 3 complete. Full marks. Okay, question 4i. Okay, it says find the differential in the form px over qx, where px and qx are fully factorised quadratic expressions. First thing we should be thinking is quotient rule, v du minus u dv. That's it. That's all we should be thinking right now. So if I zoom in a minute, what do we have here? V and u. Okay, so we know it's v du minus u dv over v squared. And what we should also be thinking for I is that we write everything down. V, x minus 3. dv, the differential of x minus 3, 1. U, 2x plus 5 all squared. du, okay, remember this is chain rule. The bracket, if we differentiate the bracket, something to the power of 2 differentiates to 2 something to the power of 1. So in this case it's 2 bracket 2x plus 5. And then we're going to multiply by the differential of the bracket. 2x plus 5 differentiated, we know is 2. So I'm going to write multiplied by 2. I'm just going to rewrite that because this is now going to become 4 lots of 2x plus 5. And then we have v squared, which is in fact x minus 3 all squared. Okay, and I'm just going to leave it like that. We don't need to expand it. There's no need. We'll get there later. Now, what are we going to do? We are going to write this all out. So let's get a different colour pen. V is x minus 3 multiplied by du. Okay, so x minus 3 bracket 4 bracket 2x plus 5 minus u 2x plus 5 squared dv times 1. That's nice and easy, isn't it? Over, oh, that is a straight line, x minus 3 all squared. Perfect. Okay. Because on the numerator we've got minus, I'm going to expand everything and simplify the numerator because it does say in the question are fully factorised, okay? On the numerator, this is not fully factorised. You never know, it might simplify down even more. So then, oh, here we go. Let's see. So, what I'm going to do first of all is I'm just going to write it out. So if I multiply that 4, I'm going to get 4x minus 12 in the bracket on the left-hand side. 2x plus 5 minus 2x plus 5, 2x plus 5, okay? I'm just doing the numerator for now. I'm going to leave, the denominator is factorised. X minus 3 squared, that is fully factorised. We can't get that any smaller, okay? And you never know, it might cancel out. So I'm going to get 4x times 2x. ax squared minus 60 minus 24x plus 20x. Okay, now on this side, please watch out for this minus, okay? What I'm going to do to make sure, and this is always useful, write the minus, expand as normal the brackets, but just put it all in one bracket. For example, 4x squared, 5 times 5, plus 25, plus 10x, plus 10x. So you can now see we are going to minus that whole bracket, okay? And it's really important. Again, I'm probably writing a few too many steps, but it's good that we understand what's going on. Okay, so now I'm going to do this part in my head, okay? So 8x squared minus 4x squared. On the numerator, I'm now going to get 4x squared, okay? I've just realised I've lost something. I think that should have been an x here. Yeah, 4x times 5. Okay, perfect. Now, minus 24x plus 20x is minus 4x. And then I've got 20x here. So I've got minus 4x minus 20x, minus 24x. Then I've got minus 60 minus 25, which is minus 85. Okay, over x minus 3 squared. Okay, I'm not going to begin to attempt to factorise this in my head. What I am going to do is I'm going to go over to my calculator and I'm going to solve it and see, because I really don't want to do the AC method. So my A is 4, my B is minus 24, and my C is negative 85. Okay, I'm going to put this in the calculator. I get my x1 equals 17 over 2, and my x2 equals negative 5 over 2. Okay, so this tells me that to factorise this on the numerator, what I'm going to have is, obviously for x1, if this is 17 over 2, it's positive, it's going to be negative here. Okay? And it's x minus something equals 17 over 2. If I work backwards, this is actually going to give me 2x minus 17. Okay? And then the same again, if I work backwards, I'm going to get 2x plus 5. Okay? It's a little trick to pick up. I'll make a video on it. But it just means sometimes, you know, when you're in a rush in the exam, you don't want to spend time doing the AC method. It's really quick to do that. You've just got to make sure you really understand what's going on. And there we go. That is completely, fully factorised. Okay? So there's 6 marks for you. Okay. Part B. Okay, so hence find the range of values of x for which f of x is increasing. Okay. When f of x is increasing, our gradient, okay, needs to be greater than 0, doesn't it? Okay, so that means f dash of x needs to be greater than 0, because that's when a function is increasing. For this to be the case, that means that our numerator needs to be greater than 0. So we want 2x minus 17 over 2x plus 5 to be greater than 0. Right? Do you remember, you know, if we're thinking if this is a positive quadratic and we have a graph greater than 0, we know, and I'm going to carry on up here. Okay, we've got this quadratic. Where is it greater than 0? It's greater than 0 here and here, okay? This is like going back to pure 1 and looking at the discriminant. This value we know from solving the quadratic is minus 5 over 2, and this value is 17 over 2. So that means we need x to be greater than 17 over 2 and x to be less than minus 5 over 2. Okay, part II. II, Captain. Okay, so g of x equals x multiplied by the function root sine of 4x. What are we thinking? Product rule. Okay, well I hope so. Wait there, I've just got ahead of myself. I'm assuming it's a differentiation question. So the curve of the equation y equals gx has a maximum point at the point M. Okay, if it has a maximum, that's when our gradient equals 0. So we are going to have to use the product rule and to find our gradient function. Show that the x coordinate of M satisfies the equation. Perfect. So then, here we go. We want to find g dash of x So g dash of x. Okay, let's get a different colour. V du plus u dv. Doesn't matter where we have our v or our u. So our v is x, dv 1. Our u, we're going to write this out, sine of 4x to the power of a half. So we're actually going to have to use chain rule on this as well. Then du, okay, remember we're using chain rule. So bracket to the power of a half, differentiate that. We're going to have a half bracket and take away 1 to the power, to the minus a half, okay? And then just write what you normally would, whatever was in the bracket. We're going to multiply this by the differential of the bracket. Now we know sine cos minus sine minus cos. Okay, we know sine differentiates to cos, okay? So it's going to be cos of 4x, but we've got to use double chain rule because sine of 4x differentiates to cos of 4x multiplied by the differential of the bracket again, which is actually, in fact, 4 cos of 4x, okay? Now we've worked all this out. Let me just tidy du up slightly. A half times 4 is 2 cos 4x sine of 4x to the power of negative half. Perfect. Now what am I going to do? I'm going to actually work this out. V is x multiplied by du. So it's these two I'm multiplying. I'm going to go straight ahead and just write 2x cos 4x sine 4x to the negative half minus u, which is this one, dv. Oh, that's nice and simple, really, isn't it? Sine 4x to the power of a half. Perfect. Okay, this is the differential done. Now I've got to make this equal to 0 because we know if we're looking for a maximum point, our gradient is 0 at our stationary points. Our maximum or minimum, our gradient is 0. I'm now going to put this equal to 0. Okay, I'm going to skip a step though, everyone, and I hope we're happy with this step. Okay, if I put this equal to 0, instead of writing out again, I'm just going to write it there, okay? Right, so now it's equal to 0. How am I going to solve this? I know the only way to get a tan is if I have a silly cow. Sine over cos, isn't it? How am I going to get a silly cow? I'm going to have to divide by a cos, essentially. Okay? So here we go. What I'm going to do is, okay, I'm going to have 2x cos of 4x sine of 4x to the minus a half, which actually I could write as sine of 4x root. Everyone happy with that? Instead of writing that, okay, equals sine of 4x, and to the power of a half is actually root. All I've done is I've moved that minus here. Actually, this is going to work out quite well. I can multiply both sides by root sine of 4x. Okay? So then I'm going to have 2x cos of 4x. Root of something times root of something is just that something, isn't it? If you think back to, you know, root a times root a is in fact a. So this is just going to equal sine of 4x. Guess what, everyone? I'm going to get my silly cow. Divide both sides by cos. 2x equals sine of 4x over cos of 4x. Well, what do we also know that sine over cos is? Tan. So I'm going to get 2x equals tan of 4x. In the question, it says tan of 4x plus kx equals 0. Okay, so I'm going to write tan of 4x minus 2x equals 0. Therefore, k equals negative 2. Look at that for a nice, easy 5 marks. Okay, question 5a says use the substitution t equals tan x to show that the equation 12 tan of 2x plus 5 cot x sec squared x equals 0 can be written in the form 5t to the power of 4 minus 24t squared minus 5 equals 0. Okay, so we've been given the substitution, but if you look closely, we've been given tan x and we have tan of 2x. So we are going to have to use the double angle formula. So we know that tan of 2x equals 2 tan x over 1 minus tan squared x. We know that tan squared x is the same as writing tan of x all squared. Okay, cot x we know is 1 over tan x, and sec squared x is in fact 1 plus tan squared x, which I'm going to write like this. So now I've gotten all of these, I'm going to write this in. So 12 bracket tan of 2x, which is 2 lots of tan x, which we know tan x is t. So it's 2 lots of t over 1 minus tan x, which we know is t squared, plus 5 lots of cot, which is 1 over t, because it's 1 over tan x, multiplied by sec squared x, which is 1 plus tan squared x, which is t squared. So I've just used straight substitution equals 0. I'm now going to simplify this. So I'm now going to have 24t over 1 minus t squared plus, and then I'm going to have 5 over t bracket 1 plus t squared equals 0. So what I am going to do is multiply everything by t and 1 minus t squared. So I'm going to get 24t times t times 1 minus t squared, and that's over 1 minus t squared, plus 5t, 1 plus t squared multiplied by t multiplied by 1 minus t squared equals 0. Okay, so this is to make sure if I multiply, I am going to get some cancel. So 1 minus t squared is going to cancel with 1 minus t squared. Then also t is going to cancel with t. So I'm now going to have 24t plus 5 lots of 1 plus t squared, 1 minus t squared equals 0. So I'm now going to expand and simplify. So 24t plus 5 lots of t to the power of 4, plus 1. Because I'm going to get minus t squared plus t squared, which is 24t plus 5t to the power of 4 plus 5 equals 0. So I'm going to get 5t to the power of, 4, but I've written a 5, plus 24t squared, that should be, because remember I had my t times t here, plus 5 equals 0. Let's double check that's what they asked for. They did, but they've got minuses. Okay, I've gone wrong somewhere. Let's see where I've gone wrong. This is minus t to the power of 4 because t squared times, so that's minus t to the power of 4. So that's minus, perfect, yep, so they just moved on to the other side. So 5t to the power of 4 minus 24t minus 5. Always double check for that. It's okay to make mistakes as long as you can look back and see where you've got them. Then part B, which I'm going to do up to here, says hence solve 0 is less than or equal to x is less than 360 degrees. The equation of this, show each stage of your working. Okay, so we're already told that tan of x equals t, and we've just asked to put this in this form, and it says hence solve, so we need to use what we've got. We're also in degrees, so make sure your calculator's in degrees, not radians. And then now, I've got 5t to the power of 4 minus 24t minus 5 equals 0. So I need to, t squared. Oh, don't forget that t squared down here. Equals 0. Now I'm going to factorise this. We're going to have 5t squared and t squared. Two numbers that multiply to give me 5. But they're going to add to give me minus 24. So that's going to have to be a minus 5 and a plus 1. So I'm going to get t squared equals negative 1 over 5. I'm going to get t squared equals 5, okay? Now, t is then going to give me, I'm not going to get plus or minus root negative 1 over 5. So this is rejected. But I'm going to get t is plus or minus root 5. So now I've got t is plus or minus root 5. I know then that tan of x can equal root 5, or tan of x can equal negative root 5. So what I need to do is find these solutions. So step 1, calculator must be in degrees, okay? And then if I do shift tan of root 5, I get x equals 65.9 degrees. Oh, I don't know what happened there. Okay, and then I'm going to use my cast diagram. C-A-S-T. So we're about 65 degrees. It's going to be here. Okay, if I start at 0, go all the way round, this is going to be 180 plus. So plus 180. So I'm also going to have 245.9 degrees. Then if I carry on, and I do shift tan of minus root 5, I get minus 65 degrees, which is here. Okay, so that's going to reflect here. So we know that this is going to be 65.9 degrees. Now remember, we're going to start at 0. We go around. So this is 180 minus, which is going to give me 114.09, which is 114.1 degrees. And then if I go around here, I'm also going to get 360 minus 65.9. Which is 294.1 degrees. So my final answer, and if I round everything to 3 significant figures, I'm going to get x equals 65.9 degrees, 114 degrees, 246 degrees. Oh no, sorry everyone. It says 1 decimal place. Always read the question. Okay, 114.1 degrees, 245.9 degrees, and 294.1 degrees. And as you can see, I put it in ascending order. If you're not sure how to get all of these using the cast diagram, please refer to a video that I've made previously. Okay, so question number 6. Figure 2 shows a part of the graph of the equation y equals f of x, where f of x equals 2 modulus 2x minus 5 plus 3. The vertex of the graph is at the point P shown. State the coordinates of P. So here, our vertex of the graph, P. This is essentially going to be the point where we would, where the modulus is. So imagine where the modulus is, what we're going to do is we're going to put that equal to 0. Okay, so it's where this modulus equals 0. So 2x minus 5 equals 0. 2x equals 5, x equals 5 over 2. And then how do we find our y-coordinate? I'm going to substitute that in, but if we think this is where this equals 0, so we're going to get two lots of 0, so f of x is going to equal 3. So our y-coordinate is 3, so we have 5 over 2, 3. So here's our coordinate. Part B says solve the equation f of x equals 3x minus 2. So for part B, f of x equals 2 modulus 2x minus 5 plus 3 equals 3x minus 2. Now we're in fact going to have two different solutions. We're going to have one where the modulus is going to be two lots of 2x minus 5 plus 3 equals 3x minus 2. And then we're going to have a set of solutions where we're going to have two lots of, and we're going to multiply everything in the modulus by minus 1. So minus 2x plus 5 plus 3 equals 3x minus 2. So for the first one, we're going to get 4x minus 10 plus 3 equals 3x minus 2. 4x minus 7 equals 3x minus 2. X equals 5. And then we're going to have minus 4x, 2 times 5 is 10, plus 10 plus 3 equals 3x minus 2. So I'm going to get 13 equals 7x minus 2. 15 equals 7x, so x equals 15 over 7. Again, that's simple rearranging. We should be very happy with that. So we have two solutions, x equals 5 and x equals 15 over 7. So solve the equation. We've solved it. We've got two solutions. Perfect. Okay. Part C. Given the equation f of x equals kx plus 2, where x is a constant, has exactly 2 roots. Okay, so now we have a straight line, which we're not sure of the gradient, but we know is going to cross at 2, which is actually below p, because we know that p is 5 over 2, 3. We know that this is 0, 3. Okay, so, sorry, not 0, 3, 0, 2. So imagine we've got a straight line between these 2 points. Well, the gradient of this line, this means that this line is only going to intersect once. So we know whatever the gradient of this line is, it's got to be more than. So we can find one of our values by finding the gradient of this line. So we're going to have y2 minus y1 over x2 minus x1. So we're going to have 3 minus 2 over 5 over 2 minus 0. We're going to get 1 over 5 over 2, which is in fact 2 over 5. So we know that k has to be greater than 2 over 5 for it to have at least 2 solutions. Then if we come back to the graph, no matter what gradient we have, it's going to keep crossing until we get to a gradient more than this line here. Or equal to. If we get the same gradient as this line, then they're going to be parallel, so they're not going to intersect. Okay? The same with this line, but this line is going to give us a negative gradient. We've always said the gradient has to be greater than 2 over 5 anyway, so we can reject that line. So it needs to be greater than this, so it's not parallel. Okay, so we need to find the gradient of this blue line here, which we know, because we worked it out earlier, if we take the positive, it's 4x minus 7. So this line is actually y equals 4x minus 7. So the gradient is 4. So that means that our gradient for this has to be less than that. So actually we're going to have k is less than 4 but greater than 2 over 5. So that for whichever gradient is going to, our line is going to be in between these points to make sure we get 2 points of intersection. So, question 7. Figure 3 shows a sketch of part of the curve of the equation y equals 2 cos of 3x minus 3x plus 4, where x is measured in radians. The curve crosses the x-axis at the point as shown in figure 3. Given that the x-coordinate of P is alpha, show that alpha lies between 0.8 and 0.9. So what I'm going to do is I'm going to substitute in 0.8, substitute in 0.9, and if there's a change of sign, I know that alpha must lie in between that. So for part A, I'm going to get y of 0.8 equals 2 cos 3 lots of 0.8 minus 3 lots of 0.8 plus 4, which is going to give me 0.13. And then if we substitute in 0.9, we're going to get 2 cos 3 lots of 0.9 minus 3 lots of 0.9 plus 4, which is going to give me minus 0.51. Okay, so change of sign, therefore root. Okay, part, it says the iteration formula x of n plus 1 equals a third arc cos 1.5 xn minus 2 can be used to find an approximate value for alpha. Using this iteration formula with x1 equals 0.8, find 4 decimal places the value of x2 and x5. So, for part B, I'm literally going to put into my calculator 0.8 equals ants. Okay? I'm then going to put in 2 cos 3 times ants minus 3 lots of ants plus 4. That's going to make it so much easier when I'm trying to find the iteration formula. And then if I do it once, I'm going to get 0.8327. Then if I keep pressing equals, 0.8110, and make sure that you do it to 4 decimal places. Okay, then part C. The point Q and the point R are local minimum points on the curve, as shown in figure 3. Given that the x-coordinates of Q and R are beta and llama, respectively, and that they are 2 smallest values of x at which local minima occur, find using calculus the exact value of beta and the exact value of llama. Okay, so we know local minimum points only happen when the gradient is 0. Minimum or maximum points only happen when the gradient is 0. So I'm going to have to differentiate this. So y equals 2 cos 3x minus 3x plus 4. Okay, so we know when we differentiate cos, we're going to get minus sign, and we're going to have to use chain rule. So let's just get a different colour. So we know we've got sine, cos, minus cos. So when I differentiate cos, I'm going to get minus sine. So my differential is going to be 2 lots of cos 3x differentiated is minus sine of 3x multiplied by the differential of the bracket because we're using chain rule. So we're going to multiply it by 3. And then minus 3x differentiated is minus 3, 4 differentiated is 0. So if we tidy that up, minus times 2 times 3 is minus 6 sine of 3x minus 3. So now we need to find when this equals 0. So I'm going to get minus 6 sine of 3x equals 3. So we can get sine of 3x equals 3 divided by minus 6, which is minus a half. Okay? Now, it wants exact value. So when I'm looking at exact value, I'm thinking radians. So please put your calculator into radians. Okay, let's just substitute. So I'm going to do shift sine of minus a half, which is going to give us minus 1 over 6 pi. So sine of 3x, 3x equals minus 1 over 6 pi. Okay. Let's get our favourite diagram out. cast. Okay, minus 1 over 6 pi, we know is roughly here. Okay, so we're going to have to go here. So this is pi over 6 and pi over 6. We know using the task diagram 0, pi, 2 pi. So if I go around, starting here, my first solution is pi plus pi over 6, which is going to give me pi plus pi over 6 which is 7 pi over 6. Okay, and then we're going to look for our next solution, which is here, which is 2 pi minus pi over 6. 2 pi minus pi over 6 is 12 over 6. I'm going to get 11 pi over 6. I've got to keep going because, as we know, we've got 3x, so we need to change our interval. If we're going between 0 is less than x is less than or equal to 2 pi, we're now going to go 0 is less than x is less than or equal to 3 pi. Now remember, it clearly states it just wants the minimum. So if you think here on the graph, I've got minimum, maximum, which is given as our next value. Now I want the minimum, so it's our third minimum. So I've got to go around. Again, this is 2 pi, this is now 3 pi. 3 pi plus pi over 6 is 3 times 6 is 18, so I'm going to get 19 pi over 6. Now, because it says in the question, given the x-coordinates of q and r and beta and llama respectively, and that they are two smallest values of x for which local minimum occur. So what people always assume, so this 7 pi over 6, remember this is given as the answers of where our gradient equals 0, is going to give us this value here of q. The next point where our gradient equals 0 is 11 pi over 6, which is our actual maximum point here. Then the last point is 19 pi over 6, which is our minimum point here. So our two values that we're going to look at are these two. We're going to reject 11 pi over 6, because that's a maximum. So now I'm going to get 3x equals 7 pi over 6 and 19 pi over 6. I need to divide everything by 3. So x equals 7 pi over 18 and 19 pi over 18. So find using calculus the exact value of beta and llama, which are, in fact, our x coordinates. Yeah, so that means beta equals 7 pi over 18 and llama equals 19 pi over 18. It's really important that we understand that when we put the gradient equal to 0 when we're finding our solutions in order, it's going to give us these solutions in order. Okay, so in this case it's minimum, maximum, minimum. So when in doubt, graph it out if they haven't provided the graph for you. Okay then, so question 8. Find using algebraic integration the exact value of the integral between 42 and 3 of 2 over 3x minus 1, given your answer in its simplest form. Okay, the first thing we should be thinking when we see this is we've got 2 over and we have x to the power of 1 essentially. Whenever we integrate this, we're going to get a ln. Okay, and we need to use chain rule because we're going to integrate. So for part 8i, so we're going to get the integral between 42 of 3, and this is the same as saying 1 over 3x minus 1. If I take 2 out the bracket, I've got 2 lots of that. So it's 2 lots of this with respect to x, okay? Now, the integral of 1 over, where we have x to the power of 1, because if you think about when we integrate, x to the power of negative 1, if we increase the power by 1, we're going to end up with 0. So when we integrate an x to the power of negative 1, it becomes a ln. Okay, so you should, so this is going to actually equal 2 lots of ln of 3x minus 1, and Then we're going to divide by the differential of the bracket. The differential of 3x plus 1 is 3, divide by that, which means this is over 3. And then obviously plus c, but we don't need to have a constant of integration when we're finding the exact values, okay? So we don't have to worry about that, but it's always good to remember when we're integrating. But we will have to put this into our square brackets of 42 and 3. Now I'm going to tidy this up. I'm now going to have, to find the exact value between 42 and 3, we're going to have 2 over 3 ln 3x minus 1. So I'm going to get 2 over 3 ln of 3 lots of 42 minus 1 minus, and then I'm going to substitute in my bottom value of 3, which is 2 over 3 ln 3 lots of 3 minus 1. Perfect. So now I need to work this out. 3 lots of 42, if I put this up here, so we're going to get in our first bracket 3 ln, okay, ln of 42 times 3, 126, 125, minus 2 over 3 lots of ln 8. Okay, now remember log laws. A log b is the same as log b to the power of a, isn't it? So this is actually going to be ln of 125 to the power of 2 over 3 minus ln to the power of 8 to the power of 2 over 3. 125 to the power of 2 over 3 is 25 because it's a cube root of 125, then squared, isn't it? We should just know that. So this is ln of 5, and the cube root of 8, 2, square that, we're going to get 4. Ln of 4, when we take away ln's from each other, we divide. Sorry, that's 25, that's 4. Take away ln's, divides, this becomes ln 25 over 4. Done, we found the exact value. Okay, part II. H of x equals 2x cubed minus 7x squared plus 8x plus 1 over x minus 1 squared, given that h of x equals ax plus b plus c over x minus 1 squared, where a, b and c are constants to be found, find the integral of h of x dx. Okay, first of all, we've got to simplify this. So we need to find a, b and c. So here we go, we've got 2x cubed minus 7x squared plus 8x plus 1 over x minus 1 squared needs to equal ax plus b plus c over x minus 1 squared. Okay, so that means we're going to have x squared minus 2x plus 1. Okay, we're going to have 2x cubed minus 7x squared plus 8x plus 1. Now, my favourite type of long division, the way we remember it, I'm a silly Billy. Into, multiply, subtract, bring down, okay? So, 2x cubed, x squared goes into that by what? It's 2x. Okay, now I'm going to multiply 2x times x squared, 2x cubed, 2x times what is 2x? Is going to be negative 4x squared, 2x times 1 is 2x. Okay, subtract, minus x squared minus minus 4 is minus 3x squared, 8x minus 6x is, plus 6x, and then we're going to bring down the 1. Okay, now I'm going to say to myself, right, what times minus 3x squared? Minus 3. And then I'm going to multiply minus 3, so I'm going to have minus 3x squared plus 6x and minus 3. take them away from each other. Minus 3x squared minus minus becomes 6x minus 6x. 1 minus minus 3 becomes 4. So, nice and easy, that's going to equal 2x minus 3, and then our remainder is plus 4 over x minus 1 squared. Now what we're going to do is we're going to integrate this. So to find the integral of 2x minus 3 plus 4 lots of x minus 1 squared, which is x minus 1 to the power of minus 2, okay, with respect to x. So now I'm going to integrate this, which equals, okay, increase the power by 1, divide by the new power. So I'm going to get 2x squared divided by 2. Increase the power by 1, 3x. Okay, now here what we're going to use is, if I increase the power by 1, minus 2 increased by 1 is minus 1. Divide by the new power, so 4 divided by the new power is minus 4, and then I need to divide by the differential of the bracket, which in this case is 1. So this is going to give me, and then plus c, x squared minus 3x minus 4 over x minus 1 plus c. And this is what, this is just what the integral equals. Okay, question 9. So, f of theta equals 5 cos theta minus 4 sin theta. Express f of theta in the form r cos theta plus alpha, where r and alpha are constants. R is greater than 0 and 0 is less than alpha, which is less than pi over 2. Give the exact value of r and give a value of alpha in radians to 3 decimal places. So for part A, we want to express it in the form r cos theta plus alpha. So if we have a look at the rule, okay, we know this is going to be, it's going to be r cos theta cos alpha minus r sin theta sin alpha. Okay, so when comparing coefficients, we have 5 cos theta minus 4 sin theta. So that tells me that 5 cos theta, equals, 5 equals r cos alpha, and negative 4 equals, not negative 4, positive 4 equals r sine of alpha, so that means tan of alpha equals silly cow 4 over 5. So alpha equals, and we've got to have our calculator in radians, shift tan 4 over 5, 0.6747, 0.6747, 3 decimal places, alpha equals 0.675. To find r, we're going to do the square root, 5 squared plus 4 squared, which is 25 plus 4 is 16. R equals root 41. Perfect. So if we're going to write that in that form, we're going to get root 41 cos of theta plus 0.675. Perfect. Then part B, I. The curve of the equation y equals cos theta is transformed onto the curve of the equation y equals f of theta by a sequence of 2 transformations, given that the first transformation is a stretch and the second transformation is a translation. Describe fully the transformation that is a stretch. Well, it's been stretched by root 41 in the y direction because it's outside the bracket. So stretch root 41 in y direction. Okay, it's been stretched out like this. And then part B, it's inside the bracket. So it's been translated by minus, because we do the opposite. So this is translated by minus 0.6750. Okay, and I'm just going to put to the left. Actually, no, I'm not going to write to the left. I'm going to draw an arrow to the left. Okay, and I've written by what vector it's been translated by. Then part C says, given that g of theta equals 90 over 4 plus f of theta all squared, and theta belongs to a real number, find the range. Okay, so we know. So if we think about the range of values, it tells us in the question that that alpha is between 0 and pi over 2. For cos, we know if we were to draw the cos graph, between 0 and pi over 2, it's all positive. So we know that we've got 0 up to 1. So we know that cos is either going to, so this cos of theta plus 0.65, this is either going to be between 0 or 1, and this is going to find our range. If we say this is 0, we're going to have g of theta equals 90 over 4 plus 0 squared, which is 90 over 4, which is 22.5. Or, as it tends to 1, we're going to have 90 over 4 lots of root 41 times 1, which is 90 over 45, which equals 2. So that means our range of values is going to be in between 2 and 22.5. So our final answer is going to be written as 2 is less than or equal to g of theta, which is less than or equal to 22.5. So remember, always refer back to the graph and think about what would happen as it tends to the minimum or maximum point. So thank you so much for listening to this video. Again, if there are certain things I skipped over, that's because we're doing an exam paper walkthrough. This isn't how to actually, this isn't a video about how to complete these questions. If you need to look at those videos, please look at my explanations of the chapters. Thank you, and give this video a like. Also, don't forget to hit subscribe and tell all of your friends.